Thank you, students. Today we discuss about Archimedes principle. What is Archimedes principle? When a solid object is partly or fully immersed in a fluid in rest, must be in rest, it loses a part of its weight apparently, and the loss of weight is equal to weight of the fluid displaced by the solid. অর্থাৎ যখনই কোনো একটা সলিড অবজেক্টকে আমরা কোনো ফ্লুইডের মধ্যে মাস্ট বি সেটা রেস্ট ফ্লুইড হতে হবে, যদি ইমার্জ করে দিই সেটা পার্টলি হতে পারে অথবা ফুললি হতে পারে, তখন ওই সলিড অবজেক্টটা কিছুটা ওয়েট তার লস করে। এই ওয়েট লসটা কার সঙ্গে ইকুয়াল? না, ওই ওয়েট লসটা হচ্ছে ডিসপ্লেসড লিকুইডের যা ওয়েট হয় তার সঙ্গে ইকুয়াল। এবং এর জন্য এই যে ওয়েটটা লস হয়, সেটা লস হয় কী কারণে? না, যখনই কোনো অবজেক্টকে ফ্লুইডের মধ্যে আমরা ইমার্জ করলাম তখন ওই অবজেক্টটার ওপরে লিকুইড একটা আপওয়ার্ড ফোর্স অ্যাপ্লাই করে। সেই আপওয়ার্ড ফোর্সটাকে বলি আমরা বাউয়েন্ট ফোর্স অর আপথ্রাস্ট। দ্য আপওয়ার্ড ফোর্স অ্যাক্টিং অন আ body when partly or fully immersed in fluid is called buoyancy. এই যে বাউয়েন্সি হচ্ছে জন্য অবজেক্টটা তার অ্যাপারেন্ট ওয়েট লস করে। তার মানে buoyancy is equal to the apparent weight loss of the immersed object. And also from the Archimedes principle we know that this apparent weight loss is equal to the weight of the displaced liquid. So buoyancy is equal to apparent weight loss, that is equal to weight of the displaced fluid. Now this buoyant force or buoyancy depends on three factors. First of all, it is the volume of the immersed part of the solid, and it is the directly proportion. That means if the immersed part of the solid is more, the buoyant force will be more. More the immersed volume, more the buoyancy. For this, in the second figure, the immersed part is more than this. So the buoyant force is more on that object than it. Here the object is fully immersed and the buoyant force will be maximum here. After that, if you move this object in downward direction, that means within the object, buoyant force will not be increased, because buoyant force does not depend on the depth of the liquid. Here the buoyant force will be maximum because the maximum volume, that means total object is immersed into the liquid. Now the second point is density of the liquid, that means buoyant force depends on the density of the liquid or the fluid. Higher the density, liquid exerts higher buoyancy. If you compare the mercury and water, mercury exerts more buoyant force, buoyancy than water, because of mercury have greater density than water. Also, if you compare the salty water and the normal water, the salty water exerts more pressure because its density is more due to the dissolved salt in it. That is why it is easy to swim in the sea water. Now third point is acceleration due to gravity, that means small g. Now the buoyant force is measured by the formula V into D into G. V the immersed part of the volume of the immersed part of the object, D the density of the liquid, G the acceleration due to gravity. Now buoyant force is the cause of apparent loss of weight. Already এটা আমরা পড়লাম। Now this is the buoyant force is equal to the apparent loss of the immersed object. Now the question is, after that what will be the apparent weight? apparent weight will be actual weight minus buoyant force. If the mass of the object is m, then the actual weight is mg minus vdg. Now what do you mean by actual weight? Actual weight means weight in air. But this actual weight is not the true weight of the object. Why? When you measure the weight of the object in air, air is a fluid. So air also exerts buoyant force, and due to that the weight of the object also decreases. So it is the actual weight means the weight in air is not the true weight of the object. When a body is weighted in air, the weight record in the is the apparent weight and not the true weight due to the upthrust of air. We know that the mass of the any solid m is equal to volume into its density. So if you put here in place of m equal to vd, then you get the upthrust, that is the the apparent weight will be v into d into g. This d is the density of solid, because m equal to vd, v means the volume of the solid, d is the density of the solid. So if you put here in place of m, so it will be v into d, g is there, and the buoyant force is v into small d into g. Here the small d is the density of liquid. Now if you take common vg, then you get d minus d. Now take a numerical. Find the apparent weight when a solid object is of volume 50 centimeter cube and density 2.5 gram per centimeter cube, that or cc, is fully immersed in water. অর্থাৎ যখন কোনো একটা অবজেক্টকে আমি ফুললি ইমার্জ করলাম, যে সলিড অবজেক্টটার ভলিউম হচ্ছে 50 সেন্টিমিটার কিউব এবং ওর ডেনসিটি হচ্ছে 2.5 গ্রাম পার সেন্টিমিটার কিউব, তাহলে ওই লিকুইডে যখন ওয়াটারে যখন ওকে ফুললি ইমার্জ করা হলো, তাহলে ওই অবস্থায় ওর অ্যাপারেন্ট ওয়েটটা কত হবে? সলিউশন V, that means volume of the object is given 50 centimeter cube. G is already given, it is taken is a 1000 centimeter per second square. D, density of the solid, it is given 2.5 gram per centimeter cube. Small d, the density of water is already we know 1 gram per centimeter cube. So apparent weight, the formula of the apparent weight, what is the apparent weight? Apparent weight is equal to we know Vg d minus d, Vg d minus d. So this is the apparent weight. So put V equal to 50, G equal to 1000, capital D, capital D is 2.5 and small d is 1. So after calculation you get 7500 dyne. That means 7.5 into 10 to the power 4 dyne. This is the apparent weight of that object which is fully immersed in water, and the volume of the object is 50 centimeter cube and the density of the solid is 2.5 gram centimeter cube. Thank you.